Yarana and Maeva, this is how we say hello and welcome in Tahiti, where I live and work, and where this project was realized. Just like they say aloha in Tahiti, in Hawaii, excuse me. I'm very glad to be here for the 25th anniversary of Asterisk to present the most original project I realized with Asterisk a few years ago. So what you see on this nice photo is the Boeing 787 from the local company Air Tahiti, which contacted my company, Sysnux, to build the internal communication system of the plane. Incredible, isn't it? So yes, it's incredible, and that's not exactly true, actually. Of course, the 787 does come with the complete communication system. The pilot can call the crew, the flight attendants can speak to the public and say hello and everything like that. But actually what the company really needed was a communication system for training their flight attendants and their pilots. And what we'll see is that they have built a small training platform, and the communication system, they could not afford to buy one, so that's what they said. And it was maybe not doable because it has to be on the real plane, I think. So that's what's a bit of a problem for us, for them. And they contacted us to mimic the actual system. And that's what we have done now. So I'll present this project, which was realized about 3 years ago. I'll give you context about the project. We'll see what the challenges were, the requirements that were needed for the project. We'll come to the solution then, and I will explain what the results are and if they are happy or not happy. So this project takes place in French Polynesia. How many of you know French Polynesia? Nobody? One people? No, nobody. So French Polynesia is a French territory. So I'm the second French guy from today. Maybe, I don't know where is the one. But I don't live in England, so maybe my accent is not as good as his was. French Polynesia is a French territory located in the middle of the South Pacific. You can see the map on the slide. So it's quite remote. We are about something like 400 kilometers south of Hawaii, 2,000 kilometers east of New Zealand, and 8,000 kilometers west of South America. So French Polynesia is actually huge, and it's covering about 5 million kilometers. So it's about the size of Europe, but most of it, as you can see on the map, is water. It's the Pacific Ocean only. We have about 120 islands, and not all these islands are permanently inhabited. And the main island is Tahiti, which is the administrative capital, and where the international airport is located. And the Air Tahiti, my company, are working. So maybe what you will know is what you have heard of is Bora Bora. Anybody knows Bora Bora? Maybe. So Bora Bora is well known in America because it's where the American GIs were located during the World War II. So Bora Bora actually was on the photo on the first slide. The population in Tahiti is about 300,000 people, so that's quite small. And just to summarize, what we can say is that we are a very remote location. It's not so easy to work with foreign companies. We have about 12 hours time difference with Europe, for example. As we are French, the companies they tend to go to France to find some assistance, and it's not easy because of this time difference, of course. Speaking about me and my company, this is a very small company providing consultancy services in French Polynesia. I have more than 20 years experience with Asterisk. I've been doing AGI, AMI, some development. In the very early days of Asterisk, I contributed a few functionalities. And I'm very proud to have my name in the credits file of Asterisk, still today, I think. So I can handle difficult projects like this one. So we'll come to the project itself, the challenge. So what you see on this slide is the floor map of the training cabin for the pilots and mainly for flight attendants. I hope it's readable. So what you see on the left of the slide is the cockpit where the pilot is supposed to be. Going to the right, you will see the front galley. On the front galley, there are two doors, which are in yellow on the map. So it's door left and right. Then going to the right, you have some rows of seats, only 3 for the training cabin. And then lastly, we have the central galley or aft galley. And again, you'll find there 2 doors, left and right, same. I forgot to say on the front galley that there was the instructor desk. So this is where the instructor stands, and he's got some controls to train the flight attendants. So speaking of what is needed as a communication system, it's written in French, but at the cockpit you will have one intercom. There will be one intercom on each door, and another one on the instructor desk. I think it's about it. Also, on the aft galley there are 2 bathrooms, which should be which are included in the project. I will tell you why later. So I've got a few photos of the systems just to explain. The training center is in a building in Tahiti, and in the training center, you can see maybe on the left photo, there are classical rooms. So that's very classical training rooms. Something that you don't see on the first photo. Also on the right, there is a fire room. So that's very impressive if you see that. They can put the trainees in real fire condition. And what you can see, of course, on at the back of this photo is the cabin that they built. So it does look a bit maybe artisanal, but it's what they did, and it works for them. You can see the toboggan. Then on the second photo, you have the cabin from the other side, and a few pictures of the interior of the cabin. On the right, it's a cockpit, and the doors, and the instructor deck is on the below, on the photo below. What you see also on these pictures, interesting, on the cockpit and the door, you have screens. I think you can see these screens. And the instructor can put some videos on the screens to show, for example, the airport, or to show water or fire, to put the trainees in different situations. So that's very interesting. Okay, so coming a little bit more specific on the communication system. The requirement, the main requirement is to mimic the actual system that's on the plane. So, as I said before, there are intercoms at each of the door. These intercoms at the door are used by the flight attendants. There's an intercom for the pilot, an intercom for the instructor. What you see on the photo on the right is the actual intercom that's used on the phone. Of course, we could not get this equipment for the project. And what you see also, which makes the project a bit special for communications, is that you see the exit sign on the photo at the bottom. On the exit sign, there are a few LEDs, and one of these LEDs at the middle is what they call the MCL. And this LED actually gives the feedback of the calls which are made to each of the flight attendants. I'll come back to this later. But so there are 4 exit signs at each of the doors, and when the phone rings, for example, we have to light the LED with a certain color. The intercom system needs to have a public address. You know that flight attendants deliver messages to the passengers, of course. And there were a few extras which do not really concern the communication system, but they asked us also to play sound when the fasten seatbelt sign was switched on or off. There was something to do for the toilets with the visual and sound alarm. They asked us to take care of the evacuation lighting and also open the oxygen mask trap when needed by the instructor. So that's a very special project, at least concerning Asterisk. Actually, it's a very small system because there are only 6 communication lines, 6 phones, 20 extensions. But we have some rules that are not so common, at least that you don't find usually on PBX systems. So one of the first rules was that when the pilot calls someone, well, it has priority on all other calls. So that means that, for example, if one of the flight attendant is on a call, if the pilot calls them, you have to hang up the first phone and connect the pilot immediately. Then there are other priorities from when you call from the cabin. So it's written here on the slide. When someone calls the pilot, it's star, star, double star. It's a priority. Well, you can read it on the slide, I think. So that is all. That's the priorities, and then there is one thing that was asked. It's a cabin-ready sign. So when you call that extension, what happens is that you have a single high-low sound which must be played. This is the pilot who is calling to that extension, and then just to give feedback to the pilot, you have to beep to ring back his phone, and so he knows that the cabin ready sign has been delivered to the crew. Okay. What is needed also? Well, there are conference calls, so that's not too difficult. They have. We need to handle also transfer intercepts. What was also requested was that intercom must display caller ID. And we have something like a phone book, which is written on the slide. You see all the codes. So this is not too difficult, of course. And as I said before, the LED on the exit signs must turn to different colors according to who is calling. For example, if it's a simple call from one call attendant to another call attendant, it's a green LED. But if it's a call from the pilot, the LED must be pink. And if it's an emergency call, it must be flashing. Okay. So all of this will be installed in the cabin that I showed you on the photos. It's on an isolated network. There is no connection to the real network of the company. And the project had to include most of the hardware needed, but some of it was already installed. Like there was there is an audio system. There was an audio system on the cabin, the audio amp, speakers, evacuation lighting. And of course, as in most of the projects, the budget is important. What I didn't say is that the company had already contracted someone from Europe, I think it was from England, to deliver that communication system. And what happened is that the European company was not able to deliver anything. So after much delay, the company Air Tahitian decided to break the contract they had with that European company, and they were fighting in court when they contacted us. So they needed a reasonable budget. Okay, I hope everything is correct, is clear for you on the requirements. I will now come to the solution. Well, of course, the solution will use Asterisk on the software. That was quite clear for me from the beginning. But we needed to have a proper hardware solution also. So what we used, what we needed was a small system, an embedded system. that would work unattended, that would not need much power, that would be on an isolated network. As you understand, we needed to have input-output, digital input-outputs to, for example, for the LEDs or for the and for some switches also. What we choose as a platform is the PC Engines, small PC Engines computer. Have you heard of that platform, maybe? No? Some of you? Nobody? No? So it's a small, it's a company from Switzerland, I think, that's building those small systems. They are mainly directed to network, to build the network equipment. They are low power, they are very reliable, and they have a GPIO included on the board. So this is the APU2 board on the photo. What you see at the bottom are the network. There are 3 network adapters, three Ethernet net adapters, though we just need one on this project. There's one thing that was missing on the APU board is that we need audio output. As I said, there is a public address, so we need audio output, which the APU system does not provide. So we use the simple USB sound card. Then we had to decide on what to use for the intercom. Of course, we could not find something that was looking like what is on the phone, like what is on the plane, sorry. And we choose to use Grandstream SIP phones because that's what we are using usually on other projects, and it works fine. We provided the power over Ethernet switch, and we built a custom electronic board for the interface, electric interface mainly. And then we provided some small push buttons, LEDs, power supplies, cables, etc., etc. What about the software? Sorry for folks who don't like CentOS. And I've heard that FreePBX is moving from CentOS. So, but we decided to use it as it's what we are using usually. So it was a few years ago, 3 years ago, I think. So that was CentOS 7, excuse me. We built a custom kernel for the small board, APU2 board. And of course, the main software for the communication was, is Asterisk. So at the time of this project, the long-term support version was Asterisk 16. So that's what we used. Of course, I would not be speaking here if it was not Asterisk. So on Asterisk, what is the used? At that time, PGACP channel was already standard, and the old CHAN SCP was, I think, obsolete already. So that was no-brainer. We need to talk to an audio amplifier, so we use the CHAN console. I'm not sure, maybe it's deprecated now. I'm not sure. Well, it's still working anyway. And I was hoping to be able to make the project with maybe dial plan, AMI, but it happened that it's a bit difficult actually to build everything with only dial plan and AMI for this project. I mean, so we use the Asterisk RESTful interface for what is not so simple. We also had custom scripts for the functionalities that I talked before that are not related to communications. So I'll show you just some small parts, some small configuration that we used. Here is a small part of the extension.conf diaplan. So what I show on this small part is a simple extension. So for this extension 4 star, you can see that we can. This is the I didn't remember, but this is the public address. So what we are doing for the public address is that when someone calls on that extension, we just hang up the extension if it's the channel if it's already in a call. Well, not we always hang up it, sorry, and then just dial in that channel console. So that's quite simple. And then for extension 11, just below, it's a bit more difficult. So what we are doing is calling to the stasis dial plan application and calling into the application written the asterisk REST application. Okay, so that's quite simple. Actually, the whole extensions file for this project is less than 80 lines, so that's quite simple. Most of the job is done by a Python program. So we wrote a Python 3 server for Asterisk REST interface. We used I don't know if I will be able to say it correctly, but AIOIRE library, and also another library for the GPO things. The Python code is about 500 lines, and what this small server is doing is connect to Asterisk first, then create some conference bridges. We talk about conference bridges sooner. And then we have a router function that listens to stasis starts events and then process each event as it is needed. And hopefully the server will run forever. So I've got example codes. I don't know if it's very interesting, but it's just to show how AAR application is written. So on this slide, you have what I call the conference 1.2. Which is which is used for the extensions 11, 12, 21, 22, and you see, I don't know if you can see it or not, but what you are doing here is, for example, setting the caller ID. with the information from the color channel. What we are doing also, we are using a variable to collect the DTMF that can be dialed during the call. And we have another function that processes the DTMF. And then we add the channel to the bridge that was previously created at the start of the application. At the end of the slide, we are calling in another function, which I did call appel in French, which means calling. So this is what appel is doing. It's setting a header. You remember maybe that I said it was we needed different ringtones for according to who is calling. So setting the ringtone on the GrandStream phones is done via SIP header. So this is what we are doing here. On the line below, you have another function which is called MCL. So this is setting the LED on the exit sign. And then we are originating a call. So this is where the real SIP call is going with all the options set before. And yes, we have also a variable to keep track of all the channels that are calling. So we can hang up later all these channels. So that's how the code, the Python code looks. So on the previous presentation, someone said that Asterisk RESTful interface is very nice, but maybe not as easy as that was expected always. So yes, there is a bit of code to write to have it working. Okay, let's move to the result. I've got just a few photos of the system. On the first photo, this is the instructor desk. So you see the red box. It's the PC Engine APU box. Just below the box, you have another box, a plastic box, a white plastic box. It does protect the electronic interfaces. The electronic interfaces will look like what's on the photo below. It's just to isolate the PC from electrical different voltages on the electrical side. What you see at the middle on the top is the exit sign opened. So there are many LEDs and just LEDs. And what you see on the right is below the cabin. So this is where we did all the cabling. We had to redo all the cabling because there were some cables prepared, but they were not. They were too short. Well, that was a bit of a mess. Okay, so I had a small video after this slide, but I won't play for some reasons. So I'm just a second. I'll go back to the last. Can you see my mouse? Okay, I got it. No. So we'll come to the conclusion. The main conclusion for me is that the customer was satisfied. We did the project. Took about 1 year to do this project, and they they had something that really mimic the real plane, so that's fine for them. The problems that we had, well, the Grandstream phones, or I think any SIP phone, is not well adapted for that kind of usage. What happens is that when they are doing some training, the flight attendants are put in a stressed condition. They are doing a lot of safety tests and things like that. So when they use the phones, they use it. They are a bit they are stressed, so they push on the buttons, and the phones don't really always respond very well. The phones are a bit fragile also. They have dropped the phones many times and things like that. One thing that was discovered that was not expected at all, ringing different ringtones on a phone, a SIP phone, is quite easy. We did it before, and it works well for this project also. But what they wanted on the plane, actually, there is once short ringing, and after that, no more ringing. Okay. So I don't know on the other on all phones, but on the Grandstream, for example, the ringtone, you can put custom ringtones, but it's limited, I think, to 30 seconds, something like that. And after that, it repeats. So what they said, no, you can't do that. You have to ring in just a 3-second sound, and then after that, there's no ringing. It's just the LED on the exit sign that stays on until someone answers the phone. So that was a bit surprising, and we were able to achieve it through the Asterisk REST interface by generating a first call with a ringtone corresponding to what they needed, and then hanging up and calling again with a ringtone that is silent. So that's kind of a hack, but it works. Oh yes, the Python libraries. When we did the project, they were a bit outdated. They didn't work after downloading with the Python version that we used. I don't know. I didn't check before the conference which was the version, but well, the official Python libraries from the Asterisk project at that time were outdated. So that was a bit surprising for us. Of course, the cabling was a bit difficult. The positive points, of course, that was an opportunity to learn on the Asterisk REST interface. Asterisk was called a long time ago the Swiss Army knife of telephony, and once again, it proves to be correct. We were able to do this project, and I think it was a fun project. So Maruru, this is how we say thank you in Tahitian. And if you have any question, I may try to answer you. Excuse me, I didn't.
A Raspberry Pi.
Raspberry Pi. Oh yeah, I thought about it. That uh, at the time, I thought it maybe. Uh, I think it would have after making the project. I think it would have worked, but at the time, I was a bit afraid of using that. I thought it was not industrial enough or things like that. We had a very good. I've been using the PC Engines platform for real PBX in Tahiti for years, and it's really reliable. It can be on 24 hours a day without any problem. So I was confident to use that platform. But Raspberry probably would have worked.
All right, this apologies. This is probably our last question because we're running a little bit over. So if anybody has any more questions after this, come and talk to him. Okay. All right.
It's okay?
Yeah. Apologies.
Thank you.
Thank you very much for the great talk.